In 1969, under the leadership of NASA and President Richard Nixon, Apollo 11 carrying Neil Armstrong, Michael Collins, and Edwin Aldrin landed on the lunar surface, marking the first time humans set foot on the moon in the history of mankind. Launched from the Kennedy Center, the mission had been a resounding success. More than 5 decades later, from the same Kennedy Space Center, Artemis II exited the low Earth orbit, heading for the moon. Artemis II marks the first moon mission since Apollo 11 in 1972. NASA astronauts Reid Wiseman, Victor Glover, and Christina Koch, accompanied by Jeremy Hansen from the Canadian Space Agency, became the first people in decades to reach the moon. But why did a moon mission take so long to re-achieve? Did we run out of resources? Or were the initial moon landings staged? Well, we need to first understand why the Apollo missions actually happened in the 1960s and the early 1970s. It was the Cold War, and the United States and the Soviet Union were trying to denounce superiority in every aspect they can, including technology through the space race. After the Soviets beat the United States to space, sending Yuri Gagarin, the United States was in desperate need of a comeback. That is where the Apollo missions come into the equation. Their primary goal was to secure superiority over the communist Russia in terms of astronomy and technology. But contrary to some people's belief, the moon landing was not faked. For the longest time, we thought that the moon was bone dry and had no purpose in exploration, until recent discoveries suggested that billions of tons of water are trapped in shadowed craters as ice near the poles. You see, near the poles, the sun does not rise high enough to evaporate water inside these craters. The water is completely shadowed from any solar radiation, which ultimately freezes it. This discovery is a key reason as to why the Artemis missions began. Another reason for this long break is the budget received by the NASA over the years. During the Cold War, NASA was a big priority, prompting the government to allocate over 4% of their annual funds to space explorations. But today, with more geopolitical and economic objectives being the priority, NASA only receives about 0.5% of the budget per year. This obviously inhibits the ability of the institution to conduct space missions as frequently as they used to. Why then are we going now? Well, there are three main reasons. Reason 1. The main objective of this mission is to validate the human systems. Artemis II is not going to land on the lunar surface. That job is for Artemis III. This mission will serve as a test for several life support systems so that the future Artemis missions will proceed flawlessly. It will mainly validate atmospheric control, waste management, and exercise and health of the astronomers. Reason 2. Testing the hybrid free return trajectory, which we will discuss more later in the video. And the third and final reason is to ensure safety and recovery. The Artemis II mission, as I said earlier, is a bridge to Artemis III. As the spacecraft re-enters the atmosphere, it will reignite. Traveling at a speed of 25,000 miles per hour, Orion will employ the heat shields to dissipate the energy as much as they can. This will provide the opportunity to validate the thermal protection systems of the Artemis missions. After the spacecraft lands in the Pacific Ocean, the coordination between NASA and the recovery teams to retrieve the astronauts safely will also be tested. Now, if you look closely at the path of the Artemis II mission, you will notice that it is different from previous trajectories from previous missions from the 1960s and 70s. Unlike the conventional elliptical orbit, Orion will travel a figure 8, traveling once in low Earth orbit, once in high Earth orbit, and around the moon and back to Earth. This provides the opportunity for the astronauts to travel from the far side of the moon, flying further from the Earth than anyone has done ever before. The trajectory is a hybrid of high Earth orbit and free return. As Orion approaches the moon's gravitational sphere of influence, it passes behind the lunar far side. Instead of firing its engines to enter a circular orbit, Orion allows the moon's gravity to tug on the spacecraft, bending its path nearly 180 degrees. This gravitational slingshot naturally redirects the capsule back towards Earth. This trajectory is a vital safety measure should the propulsion system fails after the initial outbound burn. The laws of physics alone will act as a free return ticket, guiding the crew home for a safe atmospheric entry without needing any further fuel. As of releasing this video, the Artemis crew will have most likely returned to Earth. As I said earlier, the Artemis II mission is a bridge to Artemis III, in which humans will land on the moon once again after 50 years. Artemis III will be the first time a woman and a man of color will be stepping on the moon. Expect a detailed coverage of that mission on the channel in the coming months. So, if you love space, astronomy, and exploration, Cosmic Horizons is the place for you.